In this unit, we're going to be talking about some consumer math, and by that, we're going to be talking about money stuff. And so we're going to talk about some basics with percents in order to talk about interest rates and tax rates and things like that that are really important when talking about how money really affects you. So we're going to start off talking about some basics. Hopefully, this is going to be a review for some of this basic stuff. We want to talk about the difference between converting decimals and percents. So, one of the things I want you to notice is that this word percent comes from two root words that you're probably familiar with, per and cent. Per means divide by. Like when you have things like miles per hour, you take your miles, divide by your hours. Cent, well, there's 100 cents in a dollar. The word percent literally means divide by 100. So the decimal 0.49 is actually 49%, because that percent sign could be translated as divide by 100. And if you go grab your calculator and take 49 and divide by 100, you get 0.49. So what we've actually done in this problem, when we want to convert from 0.49 back, is we're actually multiplying by 100, because that's how you undo division, is by multiplying. And another way of saying that is to move the decimal place to the right 2 spots. Now we can also convert between fractions and percents. The big thing to remember here is that a fraction is nothing more than a division problem. So when I talk about, hey, the fraction 1/6 is equivalent to what percent? Well, the fraction 1/6 means 1 divided by 6. And so if you get out your calculator and you do 1 divided by 6, then you get 0.166666 repeating, or 0.1666666 repeated. So if I want to find out what percent that is, I'm going to move my decimal point 2 spots to the right, get 16.6, and at some point I need to round up to the 7. So it's 16.67%. Now if I want to go the other direction of saying 36% is equivalent to what fraction, well, this is easy because of our calculator. And if we take into account what I had just said about percent literally meaning divide by 100. 36% literally means 36 divided by 100, but we could also turn that back into a fraction then. Our calculators make this easy because it reduces fractions for us. We could put in 36 over 100, and it's going to reduce that fraction for us down to 9/25. And that way we don't have to worry too much about all the reducing of fractions. Make sure you do that, though, because it is always proper to leave a reduced fraction as your answer. Let's talk about sales tax. This is a pretty important tax to talk about. It's something we pay all the time. So this first question asks, what's the dollar amount of sales tax on a suit priced at $1,738 if the sales tax rate is 6%? So what we're going to look at here is we're going to start off with a very simple way of doing this. To start off just saying, hey, let's just figure out what the tax is. And that's just going to be multiplication. 6% is 0.06, and we're going to multiply that by the 1738. And we just do grab our calculator for that. This is just a straight up calculation, so I'm not going to do it on the screen. And this would give us 104.28. So our tax on this, let me write that a little bit nicer. Our tax is $104.28. Now, if I want to find the final selling price then of how much do you actually owe for this, then we're going to take the 1738 and we're going to add the 104.28 to that, And again, you can just grab your calculator to make this a little bit easier. And that final price is going to be $1,842.28. Now suppose we have another purchase, and we're at a much worse state in this case, where the sales tax rate is 13%, and our original price was $63.69. Now I want to talk about what we just did in that previous problem and see if we can make it a little bit easier. So we calculated the tax by saying, all right, let me do a little bit of algebra here. Let's say that X is our price. Then when I found out the tax, I took my percent times the X. When I found the final selling price, I took the X and added that 0.06X to that. Well, if I just combine like terms here and I realize this is 1x, what I really did is I said, let's do 1.06 times the x. And this should hopefully make sense that 1.06 is saying one full value of the original amount as well as 0.06 more. And so what I can do that's going to be a little bit easier in this case is if I want to find the final selling price of this thing that costs $63.69, then instead of doing this as two separate steps, I can say, let's do 1.13 times 63.69. And if I do that in my calculator, I can get the final selling price in one step rather than a bunch of steps. This is going to get me $71 and about 97 cents once I round to the nearest cent. Now, discounts are going to behave in a very similar way to how sales tax behaved. If we have a skirt that originally cost $30, but then there's a sale for 15% off, we could calculate the amount of the discount by saying, let's multiply 30 and 15%, where 15% we're going to write as 0.15, and that's going to give us $4.50. And so $4.50 is how much comes off. And so if I want to find the new price, I would take 30 and subtract that $4.50 to find that the skirt now costs $25.50. Okay. Now we could do this in two steps, or we could actually turn this into a one-step problem as well. If we follow the same idea that X was the original price, then the discount would be the percent, which in this case was the 0.15, times that X. And then the sale price would then be X minus this 0.15X. And if I thought about this in terms of combining like terms, then 1 minus 0.15 gives me 0.85X. And you can think about this as saying, if you're going to take 15% off, then that means I'm left paying for 85% of it. So instead of turning this into a two-step problem, you can say, I can just start off by saying, let me figure out what 85% of it is, because that's how much I'm paying. So as a second example, if we had something that was originally priced $24, but we're going to take 11% off, then that means that we're paying for 89% of it. And so we could just take 24 and multiply by 89%. And if I grab my calculator and do that calculation, then that means I'm paying $21.36. So that's a little easier way of going about it. Now, sometimes you are going to be asked to do a little bit of algebra in solving these problems. So in this case, we have Joyce paid $130 for an item at a store that was 35% off the original price. And we want to know what was the original price. And so there's a couple ways we could go about this using algebra, but the basic idea is that we need to define a variable. And we're going to define x as the original price. Now we could go about this in a few different ways, but I think the easiest way to do this is to say if it was 35% off, then we paid for 65% of the item. So if we take 65% of the original price, then that's going to equal the 130 that we actually paid. And now to solve this equation, we can do this in a single step. We can divide by 0.65. And so we can just grab our calculator and say, what is 130 divided by 0.65? And that's going to give us 200. And this answer should make sense, and it's also something that we could check fairly easily. Because we could grab our calculator out and say, okay, what is 35% of 200? Oops, I should probably do 0.35. I missed a decimal point there. So what is 35% of 200? It's 70 bucks. So if it originally cost 200 bucks and we got 70 bucks off, that would end up being 130 bucks. So that does make sense. And make sure to check your answers like this. How long did that just take me to check the answer? I even made a mistake in checking it. I typed it in wrong. And it still took me, 5-10 seconds. Take that time to do it because we all make mistakes. And when it comes to these kinds of numerical problems, it's easy to make a mistake. So first of all, make sure your answer makes sense. That if we're looking for the original price after a sale, it's going to be more than what we paid. So the 200 makes sense for that. But then also actually plug some numbers in and double check your work. The last thing we're going to talk about now is percent change. This is sometimes called percent increase, sometimes called percent decrease, but really the idea is going to be the same. Whether you're talking about an increase or a decrease, the formula to calculate the percent change is going to be the amount of the change divided by the original amount. And so this is where it depends on whether it's an increase or decrease, what order you subtract in. But you don't have to worry about a whole bunch of fancy formulas if you keep this idea in mind. So in this particular example, we had 14.1 inches of snow that fell in the month of December. And in the month of January, the amount of snow that fell increased by 6.7 inches. By what percent did the monthly amount of snowfall increase from December to January? So in this particular example, we were actually given the amount of increase, which was 6.7. And the original amount would be the amount that happened earlier in time. So December's amount, which was 14.1. So if we just put this into our calculator of 6.7 divided by 14.1, we're going to find that this is 0.475177,305 in our calculator. And then if we're going to turn this into percent, we can just basically move the decimal place over 2 spots, giving us that this is 47 point, let's call this 52%. And so this gives us the percent increase from December to January.